Hi, I'm Mally. I got question 5 on the review, so let's just start out by reading it. At a certain temperature, a 1 liter flask initially contained 0.298 moles of phosphorus trichloride and 8.7 times 10 to the negative third moles of phosphorus pentachloride. The system was allowed to come to equilibrium via the reaction, and after the system had reached equilibrium, 2 times 10 to the negative third moles of chloride were found in the flask. Determine the value of K sub C for the reaction at this particular temperature. Let's just start out by doing the R part of our rice chart. We're just going to copy the balanced reaction that is in the problem. Since this is a reversible reaction, we do our fun little reversible arrow. It is balanced. We have 5 chlorides and 1 phosphorus. Initially, since this is a 1 liter flask, these values, like 2.98 moles, would also be 2.98 molarity, like the concentration. But we had a problem in our notes on like the second day. Yeah, it's these notes on the second page with like this same reaction where it's a 2 liter flask and the values are thus over 2. But since we don't have to do that, it's just 0.298 molarity. We don't have any of this chlorine, and we have 8.7 times 10 to the negative third of our initial phosphorus pentachloride. Okay, and then it says at equilibrium we had 2 times 10 to the negative third of this chloride. That means we had to gain 2 times 10 to the negative third moles of chloride. Which means, since this is a 1-to-1-to-1 mole ratio, that means that this also 2 times 10 to the negative third, and we had to lose 2 times 10 to the negative third over here from our reactant side. Since we had this value, we don't need to do any of that solving for algebra stuff. So if we add these, we get 0.3 molar and 0.0067, which you could also write 6.7 times 10 to the negative third. Now, we are not done here. Since the question asks for the K sub C value, we need to plug it into our equilibrium equation. Remember, that's products over reactants, so let's just write it without the numbers real quick. Products over reactants. Since we don't have any of these, like a 2 or a 3 here, we don't need to raise these to any powers. Great, and so now we're just going to take the concentrations of each of these and plug them in. So the PCl3, 2 times 10 to the negative third, and 6.7, that's not a 7. If you plug this into your calculator, you will get 0.0895, or 55, so this would just come out to 0.0896, which is what's posted on the answer key.